Hello friends, our today's topic is binary search. What is binary search? Binary search is an algorithm for finding an element's position in sorted array or to find whether the element is present in the array or not. In this approach, the element is always searched in the middle position of the array. The prerequisite of binary search is element must be sorted. If the elements are not sorted in the array, then we need to sort them first, right? Now I'll take one example and apply binary search. Here's an array. The total number of element is 10. The last index value of this array is 9. And the first index value of this array is 8. Now here we will divide is the lower bound and the upper bound. Suppose this is lower bound and this is upper bound. The value of lower bound is 0. And the value in this case, the upper bound is 9. Right? The approach of binary search is we divide this array into two halves. Accordingly, our search will lie whether in the left half or the right half, or the element will be found at the end. The element will be found at the mid position. For example, we are searching an element named key 57. Whether 57 in this array is present or not. So to divide this array, first we find the middle element. Middle element will be found by m equals to L plus lower plus upper by 2. Okay. Now, there will be three cases. First, the element we are searching will be found at middle position. If the element is equals to middle element, then we will stop our searching here and return the middle position. The second case is, it is a possibility that key element is greater than the middle element. If it is like that, then the element will be lie in the second part of the array, then right part of the middle element. And the third case is if the element is less than the middle element. In that case, searching will be lie in the left side of the middle element. Right? Now we take this example. Here I'm writing the left value, lower bound, upper bound, and the middle. Now presently we have an array of 10 elements. Lower value is 0, upper value is 9. We found the middle value, lower plus upper by 2, and we will take the floor value. So it is 4. 4 is the middle position and the middle element is 41. Okay. Now we will check the first condition. Whether 57 is equal 41. No. We will check the second case. 57 is greater than 41. Yes, right. The element we are searching is greater than the middle element. Then our search will lie in this array. Because the array is already sorted, then the largest element will lie in the second part of the array. Now, again we have to divide this sub-array into two parts. Again, we have to find the middle element of this sub-array. In this case, we have to shift this L from here to here. Now, this L value is m plus 1. So, next time, the L value is 5, that is m plus 1. Upper value is 9. Again, we will find m, that is 9 plus 5 divided by 2. We will get 7. The next time, the middle value is 7. Now, again, we will check all three cases. Key equal middle element. Key is 57. Equal middle element in this case. Now, 61. Whether they are equal? No. Next. 57 is greater than 61. No. The element we are searching is not greater than the middle element. The third case, 57 is less than 61. Yes, this is true. The element we are searching is less than the middle element. That means our searching will lie in this left part of the middle element from here to here. Right? In this case, now our array is this. This sub-array is left where we are searching. In this case, we have to shift upper value from here to here. That is, upper equals to m minus 1. Next time, L will be 5. U is 7 minus 1, that is 6. Again, we will find m. 6 plus 5 by 2, that is 5. Now, the middle element is this, 5. And the middle value is 5. Middle element is 53. Again, we will check all the three cases. First, we will check the value we are searching, 57, is equal 53. No. The second case, 57 is greater than 53. Yes, right. That means the element we are searching, 57, is greater than middle element, 53. That means our searching will lie the left part, right part of the middle element here. Now you can see in this array, only one element is left here, right? So upper value will be 6. Lower value will be m minus m plus 1. The lower value is m plus 1. Lower, we have to shift from lower here to here. So lower value is m plus 1, that is 6. Again, we will find middle element, 6 plus 6 by 2, that is 6. Now the middle value is 6. And the middle element is 50. Again, we will check all three cases. The key element we are searching, 57, is equal to middle element 57. Yes, it is here. 57 equal 57. That means we found our element at the mid position and we will stop searching here. So you can see we are repeating these many steps number of times. We are finding first middle element, then we are checking all three cases. So if we found the element, then search will stop from case 1, right? If suppose element is not there in the array, then how the searching will stop? We have to think that this condition, suppose we are searching an element 68 that is not present in the array. What happened in this case? In this case, we will shift lower value towards right. One time, the lower value will update. So to finding 68 in this array, again, we will take again the same example. First, we will find lower, upper, and middle. Now the key value is 68. We are searching in this array, though it is not present. So we will see what will be the condition when element is not present in the array. So first time the lower value is 0, upper value is 9. We will find middle element, middle value is 4. So first time the middle element is this, right? We check the 68 we are searching is greater than 41, right? So we have to shift lower value. Lower value will be m plus 1. So L will be 5. U will remain 9. Again, the middle value is 7, right? Next time, the middle element is 61. Middle position is 7. We can check here the key element 68 is greater than 61. So again, we will shift L value towards right. So L will be m plus 1, that is 8. U will remain 9. 9 plus 8, 17 by 2, that is 8.5. So middle element is 8. Now middle element is 63. Okay. again 68, that means key element is greater than middle element, then we have to shift lower value here, right? So L is m plus 1, that is 9. You will remain 9. 9 plus 9, 18, means again 9 is the middle value. Now 67 is the midpoint. 68, the key value we are searching is greater than 67. So again we have to shift L value. Then L value will be 10. You will remain 9. Here you can see the L value will become 10, which is not present in the array. So there is no point of searching anymore because the lower bound has been crossed the upper bound. So there must be the stop condition when the element is not present in the array. Means whenever the L greater than U, then we have to stop searching here. Means there is no point of searching when the lower bound crosses the upper bound. If element found, then we will stop the searching where? In this case, if element is not present in the array, then our searching will stop in this case. When lower value is greater than the upper value, we have to stop here. Right? In both the cases, the searching must be stopped. So now I will write little piece of code here. I will make a function int binary search. Here I'll pass an array int a, number of element, right? First here I will define the first element, lower value, that is 0, upper value, that is n minus 1. We are repeating 3 conditions while L is greater than equal U. जैसे ही L U से ग्रेटर हो जाता है, वैसे ही हमें क्या करना है, इस लूप को स्टॉप करना. लूप रन कब करेगा? When L is less than equals to 2. In this loop, first we are finding the middle element, that is L plus U by 2. After this, we are checking all 3 conditions, whether the key element, here we will, one element we define key element. If key element is greater than, is equal to middle element, then we return mid position. Another case is else if key element is greater than middle element. In that case, we are changing the lower bound value, that is m plus 1. In third condition, we are changing the upper value, that is m minus 1. These 4 steps will repeatedly, these 3 conditions will be repeatedly performed. If the element found, then it will return the middle position. Now, if element is not found, then it will return minus 1. Minus 1 is showing element is not found in the array. And here the function is closed. So this is the code of binary search. Here you can compare, now you can compare the linear search or binary search. You can see here, binary search is beneficial over the linear search because the time complexity of linear search is order of n. And time complexity of binary search is order of log n, which is less than the linear search, because in case of binary search, we are not searching the whole array. We are searching only in sub-array parts. So it's reduced the complexity, but the constraint is, in case of binary search, the array must be sorted. Thank you.